at section 1.6, linear inequalities and interval notation. Part A is going to be on inequalities and interval notation. First of all, an inequality is a statement that uses inequality symbols like less than, greater than, etc. instead of the equal sign that is used in an equation. So for example, if there was an equal sign there in the middle, this would be an equation and you know how to solve it. You would subtract your x's to the same side and solve for x. It's an inequality because you don't have the equal sign right there. You have, in this case, a less than or equal to sign. Okay, so we're going to be looking at inequalities here in this section. That sounds important. And it uses an inequality symbol in an equation. Okay. So there are symbols here. We have the less than symbol. We have the less than or equal to symbol, so they are the same direction, just one has no equal bar underneath it and one has the equal bar underneath it. And we have our greater than and our greater than or equal to symbols. So decide which of the following inequalities are true or false. Okay. So again, we're just refreshing ourselves on these symbols. Less than kind of looks like capital L, helps you remember the directions. So this one would be read as 3 less than 7. This is true. -6 greater than -2. So this is false. Remembering when you order negative numbers, -6 is on the left, it's smaller. Numbers get smaller on the left and larger on the right. So -6 is not greater than -2, so that's false. 6 less than or equal to 6, that's true because of the equal bar. It's allowed to equal, so that's true. And then 8 is greater than x is greater than 12. If you have a compound with 3-part inequality, it can only be true if it's true without the variable in the middle. So if you said 8 is greater than 12, x is greater than 8, which is greater than 12, fails, right? Because 8 is greater than 12 is not true. So this is false. This would only be true if you could jump from one side right to the other. So if 8 is greater than 12. Okay. Another way to think about this one is to think about it in 2 separate pieces. Is it true that 8 is greater than x and that x is greater than 12? Can both of those two things be true at the same time? X larger than 12, but 8 larger than x. Maybe reorder this one to x less than 8. If 8 is larger than x, x is less than 8. So you can't have those two things happening at the same time, right? You can't have x being bigger than 12 and less than 8. This is a common trick for thinking about inequalities. It's very hard to read them actually when they are having the number first, right? 8 is larger than x. What does that mean? It means that x is less than 8. So if we flip the variable and the number from one side of the inequality to the other, we also have to flip the sign. Okay? The point needs to stay towards the x in both cases for those two statements to be true. Handy trick. All right. Now, we're going to mention here interval notation. All right. So interval notation is a way of writing a range of values that could be represented in a number line. So the number line is going to be the graph, but we're going to write this range of values in an interval. The interval notation has a starting value, which is on the left side, and an ending value, which is on the right side. The interval notation separates the values with a comma, start, comma, end. And then there are 2 types of notations. We'll group those together. It either uses brackets to show that the endpoints are included, or parentheses to show that the endpoints are not included. Intervals that go on forever have infinity or negative infinity as their endpoints. So I'll put or negative infinity on that end over there. I could have written them both in if I planned ahead there. Okay. So if they go on forever positive, they would have infinity, and forever negative, they would have negative infinity as their endpoints. So in the table at the bottom of this page, we have a few things that are written in words. They're also already written in inequality notation. Our job is to graph them and write them in interval notation. So numbers that are less than 2 is the inequality x less than 2. In a graph, you would find 2, and you would want your numbers to be less than 2, so you would draw an arrow to the left. I'm going to draw an open circle around that 2, just to show that I've identified where 2 is, and we're going to trace it to the left. Okay. I'm also going to specifically mention that I have an open circle right there. As opposed to having an inequality that has a equal bar, that means I get to include 2. And so I'm going to do a circle there, but I'm going to fill it in. Okay? And again, that's less than or equal to, so I have to the left. So this is a closed circle. Okay, so we're going to use open circles when I have no equal bar and closed circles when I have the equal bar. All right, so let's see if we can highlight that. That's my highlighter. There's a green one. Okay, so the equal bar right there meant closed circle. Okay. All right. For the intervals, all right, once you have your graph, you can see that the leftmost number that you would be approaching goes all the way down through all the negatives, -1, -2, -3, -4. It's going to keep going on negative forever. So the leftmost value is going to be -infinity, comma, start, comma, end. The rightmost value where it ends is 2. Okay. Now, in the first case, where you have the open circle, the less than does not include, so we're going to use parentheses. Okay, again, those parentheses stand for not included. So we're not including the infinity, and we're not including the 2, and that's because of the no equal bar. No equal bar. All right. If I have the equal bar, I still have the same order. I'm going all the way down to -infinity as my lowermost value. So it always goes start to end. The start is way down here at -infinity. Comma, the end is at 2. This time, I do include 2 because 2 less than or equal to 2 is true. So I'm going to include the endpoint. I'm going to use a bracket. I use a bracket around that 2 to say that that 2 is included. Do I get to include the infinity also? Since infinity is an idea, it's not actually a number, you can't reach it. You can't reach infinity. If you think the biggest number that you can think of, you can add one more to it and be even bigger. It's not reachable, so it can't be included. Okay, so we'll make a special note there that infinity can never be reached, can never be included, even with an equal bar problem. So we can never, or cannot, that just sounds stronger to say we can never include infinity. Doesn't matter if it's positive or negative, but we can never include infinity. It's an idea. It can't be reached. The last 2 in this table are about greater than or equal to. Again, we're comparing from 2. Numbers that are greater than 2 are going to be bigger. So my graph is going to be going towards the larger values, going towards the right. And I open circle this again because there's no equal bar, similar to the first one. Open circle. Okay. Now, in the interval, this time the start value is 2, so 2 goes on the left this time. And as you go all the way up, your highest value is your positive infinity. I'm not including 2, there's no equal bar, so it's going to get a parenthesis, and infinity will always get a parenthesis. numbers greater than or equal to 2, x greater than or equal to 2. With the equal bar, we're going to do a solid dot at 2, and greater than, we're going to go to the right. So we have our closed circle. And then we have a very similar interval. It's going to go from 2 as the starting place, comma infinity. With an equal bar, I get to bracket, include that 2. Infinity is an idea that can't be reached, so it's going to have a parenthesis. Just an emphasis on this 2 is included. And it's included because there is an equal bar. Is an equal bar. Okay, in example 2, we're going to write the inequality in rotation and then graph the values of x. This is what we did on the previous page, so we just have a chance to practice again right here. So x is greater than 2, so it's not written out in words for us, but we need to read the inequality. X is greater than negative 2. So I'm going to put my circle first at negative 2, decide if I'm going to leave it open or closed. No equal bar, open. Greater than, drawing to the right. I like to do the graph before I write the interval because it helps me identify the start and the end, the left and right parts of my interval. So negative 2 is going to be on the left. Positive infinity, since the values are going to be positive as you go on, is going to be on the right. Infinity automatically gets a parenthesis. Go back and look at your symbol. No equal bar. That 2 also gets a parenthesis. So I have the inequality in interval notation and the graph. X is less than or equal to negative 1. Okay, so I put my circle at negative 1. I have an equal bar, so I fill it in. Less than or equal to, smaller. So the smallest number on the left over here will be negative infinity. That has to come first, comma. The rightmost number is negative 1. I can put my parenthesis around the infinity because I know infinity can only ever have a parenthesis. Look back at my equal bar, and I know that I need a bracket at negative 1. X is greater than or equal to 3. Circle around 3. Equal bar, fill it in. Greater than or equal to, heading to the right. Leftmost value is 3, comma, rightmost value is positive infinity. Parenthesis around the infinity. If there is an equal bar, come back and bracket your 3. Okay, in part D, I've got a 4, open circle, don't fill it in. Less than 4, left. Always do the leftmost value first, going all the way down. It will eventually go into the negatives and go all the way to negative infinity. Stopping at 4. Parenthesis around the infinity. No equal bar. Parenthesis around the 4. Okay. One more note about these. Positive infinity can only ever be on the right side. Negative infinity can only ever be on the left side because negative numbers are on the left of the number line and positive numbers are on the right. If we're feeling comfortable with those, let's take a look at some more of the two-part inequalities. And they're called two-part because there are 2 different numbers in them, our variables in the middle. These are just one part, there's only one inequality symbol. So we have some that are written in words, we have the inequality, we're going to make our graphs and do our intervals. First of all, we want numbers between negative 1 and 4 inclusive. So first of all, I'm going to highlight that word because inclusive is the word that tells us we need those equal bars. So if I had it just in words, I would need to say inclusive to include those ends. So I'm going from negative 1 to 4, inclusive equal bars, so we fill those in. And we connect our numbers. We're going from negative 1 to 4. Now, if I read the inequality, I was going my graph off of those words, right? Numbers between. If I read my inequality, I want negative 1 to be less than x. So x has to be larger than negative 1, but x has to be less than 4. So I can go from the inequality to the graph. Sometimes it's nicer to see the words right there as well. Okay. I can also see this as, if this is true, remember that it's true that negative 1 is less than or equal to 4. That's true. So I can go from the first number to the second number. Okay. So my interval. This does not go all the way down, right? These arrows on the top extended beyond the number line. They just kept going, right? They might have not drawn it all the way. I could have drawn this further, but it extends on and on and on. These numbers stop. And so since they stop, they don't go infinite. The leftmost value is -1, comma, the rightmost value is 4. That's my start, that's my finish. So first we will look for our inequalities equal bar. It has equal bar on both. So we bracket and we bracket. Both of them are included. They don't have to both be included. If I look at the next one, I have an equal bar on the -1, but not on the 4. This graph will look similar. -1 gets an equal bar, gets a closed circle. 4, open circle. They still connect. It's still between them. But I have a mix match of the symbols. So they could be both open, both closed, one open, or vice versa. So my interval on the next one, -1 to 4, closed, so bracket on the -1, and open, so parentheses on the 4. All right, so kind of want to highlight these. Like these two are similar, and then these two, the next two are similar. Okay, so in the next two, I have again two-part inequalities, but they can't be written as a single statement. So it's not numbers between two values, it's numbers that are either greater than or equal to 4 or less than or equal to -1. So they have to be written separately. They're either less than -1 or greater than 4. So less than or equal to -1, I can do them separately. I can do the graph for the first one. I fill it in from the equal bar, less than or equal to -1 or greater than or equal to 4. So they can't be written as one inequality because you're not looking at numbers between two where it would be true. You're looking at numbers below -1 and above 4. So you have these two different tails. With those two different tails, you will have two different intervals because each of these graphs is similar to the one-part graphs up here. So we're going to do the interval for the first one. The lowest value is -infinite, comma, the highest value is -1. Parentheses around your infinite, bracket at your 1. We're going to use a union symbol. It's like a capital U with no tail. It's really a little bit thicker, but that's what we're going to use. And then our next one is going to have a bracket around that 4, because we're including that 4, comma, this one goes infinite. Okay, so that U symbol stands for union, which is an and. It means I need this interval and this interval to get the complete picture to form. All right, and so the next one, again, is similar. We could do the same statement with both included, or we could do it with one included, one not, or both not. Okay, so this is going to be numbers greater than or equal to 4 or less than 1. So you could see back up here, I had the or equal to part in both, so I got my equal bars. Here I have the or equal to on the 4, but not on the 1. So I need to have an open circle at the -1, just heading less than, and greater than or equal to 4, closed circle, and then heading up. So we'll have -infinity, comma, -1, parenthesis on that -1, union. Oops, that 4 is going to have a bracket because I do want to include equal bar on that 4, comma, infinity. So this one's mixed with one parenthesis and one bracket. All right, so we've got our last example here where we want to describe the following using an inequality, an interval, and a graph. So right now they're written in words. So all the numbers between 2 and 5. If they don't tell me inclusive, I'm going to assume I'm not including the ends. So I'm going to write this as 2 less than x less than 5. Numbers between 2 and 5. So 2 and 5, open, open, connect would be my graph. So my interval would be 2 comma 5 parentheses parentheses. No equal bars there. All the numbers below 0 or above 2. I'm not including those again, so we're going to have 2 open circles here. So I'm going to say all the numbers below 0, so x less than 0, or notice up here that you have to say the word or if you're going to do 2 intervals of the same graph, or x greater than 2. So open circle at 0, open circle at 2, less than 0, below 0, greater than 2, above 2. So 2 intervals, negative infinity to 0, not included, union, 2 not included, to infinity.